You must have been to web pages on your browser and were required to submit information like your password or credit card number, which is something you don't want to share with everybody. For example, if I want to access my Gmail account, I have to send my username and password to the Gmail web server so that it can authenticate my account. But the data that I send to the Gmail server actually goes over the internet, which is kind of owned by different companies and parts. The internet service provider that you use might be Verizon or AT&T. So when you actually connect to the internet, you are on your service provider's network. Let's say Verizon for our example. So the data you send goes over the Verizon network to maybe few other networks before it finally arrives at the mail server. Now, I am not saying that one really does, but it is possible for a person in one of such companies who has proper access to the network to be able to see the data that one might send over the internet. If the data that I sent over the network is sensitive, like the credit card information while making an online payment or the bank account information, it can be a lot of trouble for people if someone on the internet is able to capture it and misuse it. Sending data over the internet following the HTTP protocol is like sending some item through a courier service without securing it in a lockbox. So a new protocol to handle secure data transfer was invented for handling valuable sensitive data. This protocol was called the SSL, short for Secure Socket Layer. And HTTPS is nothing but the HTTP protocol working in tandem with SSL. That is, in HTTPS, SSL takes care of making sure that the data goes securely over the internet. So let's understand SSL now. But before we can understand SSL, we must be aware of some concepts of cryptography on which SSL is based. Cryptography is basically the science of hiding information. For example, if we have a string, say something about Mary, we can apply some kind of mathematical transformation to it so that we get a new string very different from the original. The original text is called plain text in cryptography, whereas the resulting text is called encrypted text or ciphertext. The process of transformation itself is called encryption. The algorithm that we use to encrypt the data is called the encryption algorithm or cipher. To encrypt the data, sometimes the algorithm might use another string called a key string. Now, I can send this encrypted string to say one of my trusted friends without having to worry about others reading the original string. But for my friend to be able to read the original string, he will need the algorithm that I used for encryption, which can be one of the few standard algorithms available. But very importantly and more importantly, he will also need the same key string. The decryption algorithm will be the same as encryption algorithm, and even if another person might know what algorithm is used, that person will not be able to decrypt correctly without knowing the key string. So this is just like locking something up with a key, and one can see what is locked if they have the key. The key here is called symmetric key, as the same key is used for both encryption as well as decryption. You might imagine that encryption and decryption in cryptography is like locking the data in a box using a lock and key. We put the real data in an imaginary box and lock it using a key. Then we use the same key to unlock the box to get back the data. But with millions of users on the internet, it will be difficult and impractical to use one single key string and share it amongst all these users. Another problem would be, how do we even send the secret key securely over the internet to these users? It will be like the situation where all the houses have locks, but all the locks have the same key. What good would that be? Anybody can unlock anybody else's house too. Well, cryptography comes to rescue again. Imagine a lock that can be locked by one key but can only be unlocked by a different key. So in cryptography, there is a way by which we can encrypt the data using some key string and then decrypt it to the original using a different key string. This is called asymmetric key encryption-decryption because of the use of different keys. The key used for encryption is called the public key, while the key used for decryption is called the private key. And the reason for calling them so is because, applying it in the context of our internet example, the server can distribute the key used for encryption freely to any user who wants to send some data to it in a secure way. That is why this key is called the public key, while the key used for decryption is kept private with the server and is strictly not shared with anyone. So this one is called a private key. So if the browser encrypts the data using the public key of the server, then it can only be decrypted by the server's private key and nobody else who might be snooping around. Coming back to the SSL protocol, let's see what happens between the browser and the server.